Hi friends, in this video let us learn about MOS structure. So this is N-type enhancement MOS. So we will see what is N-channel enhancement. N-type means N-channel, right? So what is enhancement, what is N-channel, that and all we will see in the coming videos. In this video we will see only the general structure. Here we have what is the thing called the substrate, right? So the transistor is fabricated on a substrate. So MOS is fabricated on a substrate only, right? So here we have P-type substrate. The another name for substrate is body, right? So what is substrate? It is a substrate is nothing but it is a single crystal silicon, right? So it is single crystal silicon wafer, which is a substrate, and its purpose is it provides support for the MOS. It provides physical support. It provides physical support for the device. So next we will see here we have two N plus regions, right? So two N plus regions are created in the substrate. You see here we have substrate, here we have two N plus region. N plus means we know the plus indicates heavily doped, so it is N region with the heavily doped N plus region, right? So two N plus region are created in the substrate. One is called source and another is called drain, right? So this is another point we have to note. So you see next a thin layer of oxide. It is oxide layer is nothing but silicon dioxide. So above the substrate we are having one silicon dioxide layer which is acting as an insulator, right? So it is acting as an insulator is deposited over it, right? So it covers the region between the source and drain. So this oxide layer lies between source and drain. So it is very thin in the range of nanometer. So the oxide layer thickness is around nanometer, right? So here the thickness. This is the thickness. This I call it as T-ox, thickness of the oxide layer. So this we will use in the problem. Okay, so above the oxide layer, the metal is deposited on the oxide layer. You see the yellow color is metal. So from that gate terminal is taken. So in MOS we have one body. It provides physical support. In body we are having two layers are created, two terminals. So this is heavily doped N plus. This is N plus. One is called source, another one is called drain, right? Next, we are having one oxide layer above the substrate. Then one metal is deposited over oxide layer. From that, we are taking the gate or gate electrodes, right? So then you see from all the layers, we are having terminals taken out: source, gate, drain, and body. So that is the thing you have to remember. MOS is also known as insulated gate FET, because we know that gate is insulated from the substrate. You see gate, then we are having one oxide layer which is acting as an insulator. So gate is not at all connected to the device, so it is called insulated gate FET. So gate terminal normally it doesn't have any current, so it is having very less current of the order of 10 power minus 15 ampere, right? So in this range only the gate current is very small. Ideally it is zero because it is insulated. Okay, so next thing we have to remember is the length. So where the depletion region will be formed or the channel will be formed, the channel length is L. So this is another important parameter we have to remember. So L is channel length and W is width of the channel. So in two dimension we cannot see width, so actually it will be going right. So this will be width, right? So TR is oxide layer thickness. So these are all the things we must know whenever we know about the device structure. So we also know that source is a terminal which supplies charge carriers, right? So source supplies charge carrier. Drain absorbs carrier, right? So gate controls the flow of carrier. Control the flow of carrier. So these are all the things we must know whenever we are working with the MOSFET. Moreover, we know that MOSFET is a symmetrical device. So what is the main thing about symmetrical device? Symmetrical device means what? So source and drain can be interchanged. Source and drain can be interchanged. We can change without no change in device character. That is very, very important. That's why so source and drain can be interchanged. Even if you change source and drain, the characteristics of the device will not change. Okay, so next length will be in the range of you can say micrometer. Width will also be in the range of micrometer. So length will hardly be from 0.1 to 3 micrometer. Width will be in the range of 0.2 to 100 micrometer. Right. So these are all the physical structure of the MOSFET. Thank you.